So we're going to look at the relationship between acid strength and the molecular structure. Not all compounds that have hydrogen in them act as acids, and some acids are strong and others are weak, and why? Why are they? So we're going to look at the binary acids first, where you have a hydrogen bonded to another element. In order for this to act as an acid, we have to be able to donate this hydrogen ion to something else. And the two things that affect this are bond polarity and bond strength. So in order for this hydrogen to leave as a hydrogen ion, this bond must be polarized, must be a polar bond, and the hydrogen has to be at the positive end of that polar bond, because the electrons are being drawn away by this anion Y. The hydrogen needs to be lost as an H plus ion. So if we look at hydrogen lithium, the lithium hydride, hydrogen is actually more electronegative than lithium, and so this bond is polarized with the hydrogen being at the negative end of the dipole and the lithium at the positive end. This is not acidic at all. If we look at a carbon-hydrogen bond, these do not have the same electronegativity, but the difference is 0.4, which is right on the line of polar to nonpolar. So this is considered a nonpolar bond. So there's not really an imbalance of charge there. These hydrogens are not going to be acidic. Something like HF, the fluorine is very electronegative. It's withdrawing electrons, pulling them over here, making the hydrogen quite positive, even in the molecular compound, and so this will be fairly easily lost as a hydrogen ion. Any questions? Yes?
When it's over 0.4, that's when we consider it polar?
Yeah, if the difference in electronegativities between the two elements is larger than 0.4, it's considered a polar bond. But not all polar bonds with hydrogen will be acidic, because this is a polar bond, this HLI, but it's not acidic because the polarity is in the wrong direction. Looking at the strength of the bond, the stronger the bond, the weaker the acid. Because if the hydrogen is held very tightly by a strong bond, it's not going to come off, right? So if we look at these acids, HF, HCl, HBr, we can compare their bond energies. The bond energy of the hydrogen fluoride bond is the strongest, and it decreases as we go down. HF is a weak acid, HCl and HBr are strong acids. So we've got two factors in here. We've got electronegativity. So in general, as the electronegativity of that other element in the binary acid increases, we're going to tend to be stronger acid, will increase the acidity. Decreasing the bond strength also increases the acidity, and as you go down in a group, the bond strength is going to decrease, largely because of the size of the atoms. Yes? These guys do dissociate, because weaker bond, more dissociation. Yeah. This is another one of those pairs of things, opposite direction things, so easy to get mixed up. I do this for a living, and the only way I can remember this is to talk myself through it. And even then, as I'm talking through it, I sometimes realize I started in the wrong direction, and that's when I delete videos. So, if you're comparing hydrogen bonded to something else and you're going, from H2O to HF. HF is a stronger acid than H2O because the fluorine is more electronegative. But if we're comparing like H2O, H2S, H2SE, they're going to get stronger as you go down the period because these atoms, tellurium and iodine, are larger, and so the bond that they form with the hydrogen is weaker. And so it's much easier for that hydrogen ion to fall off. So that was the analogy of Mrs. K taking her 6 children to the big Fresno Fair, which I never did. I never took all of them because I like my children most of the time and I didn't want to lose any of them. And so if you're a small family, you've got 1 kid, you go to the fair, you can actually hold on to the child, or 2, you've got 2 hands, right? I've often thought when you have a 3rd child, you should grow a 3rd arm, but that would make shopping even more difficult than it already is. But if you're outnumbered by your children, if you're a bigger family, the bigger the family, the easier it is to lose a child. Yeah, not politically correct at all. I never lost a child for more than a little while. I got them all back. They were unharmed. Just to clarify. So what about the oxyacids? So oxyacids, as the name suggests, have oxygen in them. So there's going to be oxygen and this other element. The hydrogens on oxyacids are always bonded to the oxygens, always. And so if we're looking at like hypoiodous acid, HOI, the hydrogen is bonded to the oxygen. So here we have an effect from the electronegativity of this other element, this Y here. And this element may or may not be bonded to other things as well. In these examples, it's not. So here we're looking at the electronegativity of I. I is less electronegative than Br. Br is less electronegative than Cl. So what does that do? Well, the acidity is determined by the strength of this OH bond. So down here, where chlorine is more electronegative, chlorine is pulling electron density away from the oxygen, which makes this bond even more polar and weaker. And so this hydrogen will come off more easily. This is a stronger acid than HOBr because of the electronegativity. And we can see that in the Ka values. Questions? Well, you have to look at oxyacids and binary acids separately. Because with the binary acid, that element you're looking at in terms of different electronegativities is bonded directly to the hydrogen. And here the element that's different is not bonded directly to the hydrogen, it's bonded to the oxygen. And so the effect is, in a way, opposite. So the Cl is very electronegative compared to the iodine. It pulls electron density from the oxygen, which pulls electron density from the hydrogen. It weakens this bond. When this bond is weaker, the hydrogen falls off easier. Yeah, so as this becomes more electronegative, the acid becomes stronger. I know, it's just closing your eyes and mumbling. Yeah, that's exactly. And also the number of oxygen atoms that are on that Y element. So the more oxygen atoms we have bonded to the Y, the stronger the acid. This is because the additional oxygen atoms pull electron density away from Y, which pulls electron density from the OH bond and making that bond weaker. So here we have HOCl, hypochlorous acid. This chlorine has no other oxygens bonded to it. In chlorous acid, we have another oxygen here. This oxygen is going to pull electron density away from this OH bond and weaken it. So this is stronger, a stronger acid. HClO3, now we have two other oxygens on here pulling electrons away, making this weaker still. This has a Ka of 1. And then we get to HClO4 with 3 other oxygens, and these are pulling the electron density away so much that this is a strong acid, and it ionizes completely.
So it's like changing the probability density field away from the hydrogen atom.
Yeah, yeah. Right. It makes it easier for the hydrogen ion to leave because all of the electrons are getting sucked over to the other side of the molecule. So we should be able to answer questions like this. Which of the protons shown in red is more acidic? We have 2 acids here. So these are both, these both have oxygen in them, right? They're not binary acids. And they both have carbon bonded to this oxygen, right? So that's the same. What's different between these two? A has an oxygen bonded to the carbon and a hydrogen, and this one has 3 hydrogens. Are these 3 hydrogens going to pull electron density or do anything like that? No, because these are nonpolar bonds. These are going to share equally. But the carbon-oxygen bond is polar. So this is pulling electron density away, which makes this bond weaker, and the acid is stronger. This one's stronger, more acidic.
So it directly have to do with whether the bonds are polar and non-polar?
It does have to do with whether the bonds are polar or nonpolar. The reason that the oxygen matters is because it's polar. This bond is polar.
Yeah. Okay.
Having more hydrogens here doesn't do anything. It doesn't affect anything. But the more oxygens you have bonded to this Y atom, the stronger the acid is. Yes? It doesn't make a difference if it's double or single bond, really. We won't see anything like that. Any other questions? Okay.